Okay. Here I have examples of calculus 2. The first example already we have seen. This is when the setup is x equals sine theta, dx is cosine theta, d theta. When you integrate this, we have seen this example. And I have another example, which is we have seen this example also, where t is 3 sec theta, d theta is 3 sec theta tan theta, and you integrate this. Then I have an example of partial fraction integrals. So if you want to integrate x cubed minus x squared plus x plus 2 over x to the 4 plus 5x squared plus 4. So if you factor the bottom into x squared plus 1 times x squared plus 4, then this can be written as partial fraction ax plus b over x squared plus 1, cx plus d over x squared plus 4. Then you integrate this, you find the values of a, b, c, and d. Then this is the integration of this is tan inverse of x plus half ln x squared plus 4 minus tan inverse pi over 2 plus c. Then I have here integral of application of integral area between two curves. So this is, you have the right curve is y x equals e to the y, and the left curve is equal to y squared minus 2. So the area is the right minus the left, integrated from minus 1 to 1 from bottom to top. So when you integrate, you will end up with e minus 1 over e plus 10 over 3. Then here I have another example. It's polar equation and Cartesian equation. This is a conversion from polar to Cartesian, Cartesian to polar. So the A is polar to Cartesian, so you have r squared sine 2 theta equals 2. To convert this into Cartesian equation, so this is r squared sine 2 theta, this equals 2, which is r squared 2 sine theta cosine theta equals 2, which is 2r sine theta r cosine theta equals 2. But we know that r sine theta is y, r cosine theta x, that is 2yx equals 2, that is xy equals 1, which is y equals 1 over x. Then Cartesian equation to polar, for example, if you have y equals 2x plus 5, then to convert this, y equals 2x plus 5, which is y is r sine theta equals 2, x is r cosine theta plus 5, that is r sine theta minus 2 r cosine theta equals 5, that is r equals 5 over sine theta minus 2 cosine theta. And I have an application of volume by cylindrical method. So this is, you have two curves, y equals x to the third, y equals x, and you are revolving this about x-axis. So you identify the outer radius, which is x, the inner radius is x cubed, then the washer, the disk area is ax equals pi, the outer radius x squared minus the inner radius pi x cubed squared, so that is pi x squared minus x to the 6. Then the washer volume is from a to b ax dx. You integrate this, so that's from 0 to y pi x squared minus x to the 6 dx, which is pi x cubed over 3 minus x to the 7 over 7. You integrate this, you will get 4 pi over 21. So that's the area between these two curves. Then I have another application of volume by cylindrical shell. So this we already have seen. This is the volume rotated, the area between y equals x squared and y equals 8 minus x squared about x equals 2. This case the graph, the radius is r equals 2 minus x. The circumference is 2 pi r, which is 2 pi times 2 minus x. The height is f of x, which is the top curve minus the bottom curve, 8 minus 2x squared. Then the volume is from a to b, 2 pi r f of x dx, from minus 2 to 2 pi 2 minus x times 8 minus 2x squared dx. You integrate this, you will end up with 256 pi over 3. Okay. Then I have another example of the arc lengths in a polar coordinate, in the parametric arc coordinate. So the parametric is where x equals 8 cosine theta, y is a sine theta, where sine t, where t is between 0 and 2 pi. So dx by dt is minus 8 sine t, dy by dt is 8 minus 8 cosine t. Then the arc length is from a to b, square root of a, dx by dt squared plus dy by dt squared, integrated with respect to time, with respect to t basically. So this is from 0 to 2 pi, so minus 8 sine t squared plus 8 cosine t squared dt. When you integrate this, you will end up with 16 pi. So that is the arc length of this parametric equation. Then I have area of in polar coordinate. This we already have seen before. So this is r equals 6 cosine theta. Sketch the graph. So the area is, you find the area of the top half circle from 0 to pi over 2 half r squared d theta. When you integrate this, then you double this by multiplying it by 2. That will give you the area of the whole circle, which is 9 pi. Then I have here, this is representation in of the power series. So this is, we already have seen, it is d by dx of 1 over 1 plus x. So this is the same as the derivative of this power series, 1 minus x plus x squared minus x cubed and so on. So the derivative of this is minus 1 over x plus 1 all squared. Then the derivative of the power series is minus 1 plus 2x plus minus 3x squared. The signs are alternating, so this is minus 1 to the n. Then you have 1, 2, 3 and so on, that is n. Then x to the 0 to the 1 to the 2 to the 3rd to the 4th, that is x to the n minus 1. And where n is from 1 to infinity. Then I have another power series, which is ln 4 minus x. This is the same as minus integration of 1 over 4 minus x dx, which is minus 1 over 4, 1 over, this can be written as 1 minus x over 4. Then this is minus 1 over 4 integration of this power series, which is 1 plus x over 4 plus x over 4 squared plus x over 4 cubed plus x over 4 to the 4 and so on. Then this can be written in a sigma, in a sum notation, where n equals 0 to infinity, x to over 4 to the n dx. Then when you integrate this, this is the same as integrating this power series. So the integration of this is ln 4 minus x. Then the integration of the power series is minus 1 over 4 x plus 1 over 4 x squared over 2 plus 1 over 16 x cubed over 3 plus 1 over 64 x to the 4 over 4 plus 1 over 256 x to the 5 over 5 and so on. So this can be written in a sum notation, minus 1 over 4, n equals 0 to infinity. The x's are, the power are increasing, so it is to the 0, to the second, to the third, and so on. So that's x to the n plus 1, 4 to the n. So then you have 2, 3, 4, and so on. That is n plus 1. Then I have, this is Maclaurin series of f of x 2 pi x. So the Maclaurin series of this is 1 minus 2 pi squared over 2 factorial x squared plus 2 pi to the 4 factorial x to the 4 minus 2 pi to the 6 over 6 factorial x to the 6, 2 pi to the 8 over 8 factorial x to the 8, and this is basically where this can be written in a sum notation from minus 1 to the n. This is alternating, so 2 pi to the 2n over 2 pi 2n factorial x to the 2n. So to find the radius of convergence, you take the limit as n approaches infinity of an plus 1 over an. So that is, you'll end up with 0. That means the radius of convergence is infinity. That means it converges for every value of x. Then I have this example of Taylor x series for f of x equals sine x at a equals pi over 2. So this is this Taylor series. You will end up with 1 minus 1 over 2 factorial x minus pi over 2 squared plus 1 over 4 factorial x minus pi over 2 to the 4 plus minus 1 over 6 factorial x minus pi over 2 to the 6 plus 1 over 8 factorial x minus pi over 2 to the power of 8. So you can write this in a sum notations from minus 1 to infinity, minus 1 to the n, 1 over 2n factorial times x minus pi over 2 to the 2n. So to find the limit, the radius of convergence of this, we take limit as n goes to infinity, an plus 1 over an, it will end up with 0. That means the radius of convergence is infinity. That means it converges for all values of x. Then I have here centroid region, application of calculus centroid region to find the centroid of region of the area bounded by y equals 2 minus x squared and y equals x. First you sketch the region, find the intersecting values by setting 2 minus x squared equals to x. Then you will end up with a is minus 2, b is 1. Then the area is from a to b, top curve minus bottom curve dx, which is from minus 2 to 1, 2 minus x squared minus x. So you will end up with 9 over 2. So then to centroid of the region is x bar, y bar. To find the x bar, it is 1 over a from a to b f of x dx, which is 2 over 9. From minus 2 to 1, you integrate this, you get minus 1 over 2. Y bar is 1 over a from a to b, 1 over 2 f of x squared dx, which will end up with 2 over 5. That means the centroid of this region is x bar, y bar minus half and 2 over 5.
When I can't be choking on the chain, who does it blow it like a fan? When you're trying to optimize, you gotta make the sign charge. Then you maximize it, man, and look up on the right part. When we get into the find the guys with the Never show the money cause I ain't been a bypass. Survived and found the slope instantaneous rate of change. Teacher Joseph Sabota, you best not be forgetting names. The toughest part consists of all the sequences and series. Struggling with ratio and roots till I'm weary. Memorizing Taylor and Maclaurin so severely. That's a lot of information, I don't even know it clearly. I be curving when I integrate. Direct comparison, imitate. If limited approach, I hope results are n equals 0, then go with the circle to play.
Let me hit it real quick. Yeah, I'm round my boys, you know we scheming. You overestimate your skills, call you left reaming. Catch that integral, I swear, got the area under the curve. Doing zero returns, turn my TI 80 first. First, calculus, don't miss plus. Look to the right when you see the plus. Think you be so tight with your calculation, go rolling. I'm a pro, give me a call. Sure got identities, know them all. If you think you are better than me, I'ma send you to the L hospital. DYDX, you know derivatives. Y prime cosine equals sine negative. Even if you got these memorized, it ain't really no benefit. When it comes to finding maximum, I'm absolutely your relative. Let it breathe. Hey, slope, get it done. Rise over run. Concave down maximum. Yeah, I do it best. I got potential. E to X, I'm exponential. I'ma teach you this rap game. Sit down, take notes, grab a pencil. Mobbing with my main Mr. Boda. Equal that trigger, I'm a tree like so get told. Mobbing